All right, welcome everybody. Today we're going to talk about lesson number 76. This is the third conic out of 4, section 10.3, ellipsis. So you'll see tonight's homework 76 listed there. Go ahead and write that down if you need to. Again, if you printed out the notes, you should find the homework already on there. You have yet another Desmos link here that I sent you in Teams, so you can go to that link if you want to kind of easily be able to play around with the different variables and see how they affect the shape of the ellipse. Just a small note here, this is a little bit on the longer side, this homework, only because it includes both ellipses and circles, which we didn't see on the previous homework. But in the end, I still think it's pretty manageable. So just be sure that you allow yourself ample time to finish. Just like the previous lessons, we're going to go ahead and start by defining the ellipse. Then we're going to do some straightforward examples. Then we're going to need our friend completing the square. And then ultimately, we're going to work in reverse, where I give you some characteristics and you go ahead and find the equation. So an ellipse is the set of all points in a plane, the sum of whose distances from two distinct points, which are called the foci. That's how you say it, F-O-C-I, the foci, is constant. So again, the visual is really good in Desmos if you care to look. Otherwise, basically they're saying that the distance, the sum of these two distances here has to be the same no matter where you drag that point on the ellipse, okay? Obviously, let's say you drag it over here. You're going to have this distance here and this distance here. But what they're saying is that that fixed distance between them has to always be the same. The line through the foci intercepts the ellipse at 2 points called the vertices. These vertices will always be on the longer side of the ellipse. That is called the major axis, the chord that connects them. Between those two vertices, obviously, is the center of your ellipse. And then there's also something called the minor axis, and that would be the chord that connects the other two sides. So how do you know if you're going to have an ellipse that faces up and down or left to right? Well, it all depends about the equation. So again, take a look at the 4 equations here for an ellipse. Just like previous examples, there are 2 examples for more complicated versions where the center is HK, and then there are 2 simpler versions where the center is the origin. Notice that for all of these formulas, they only work if it's equal to 1. It has to be equal to 1 or else you cannot draw any conclusions. So your first order of business is making it equal to 1. So then this is kind of the key point here. They're always assuming that no matter what equation you use, that A is going to be greater than B. So if A is greater than B, whoever the A is with in the equation, so here in the first example, because the A is with the x's and you know that A is always greater, that's how you know that it's going to open left to right because that's where the x's are. In the second version, notice that the A has moved to be with the y's. So if the larger value is with the y's, that's how you know that the graph is going to open from bottom to top. Okay. Another important formula here, you're going to be asked to find the foci. Notice that the foci always exist on the major axis, and you always find them using the formula that c squared is equal to a squared minus b squared. And of course, those a squareds and b squareds come from the original formulas. A couple of more visuals here. So in the first one, again, notice that the A is with the x's. The A is always considered to be the larger, which is why you're opening from left to right. That means that the distance from all the way left to all the way right will be the major axis, which is 2A. And then, of course, it's A units from the center to each of the ends. Then notice in the other example, the A, which again is always the larger, is now with the y term. So that's why you're going to have a vertical axis here, which is the major axis. And again, the whole distance is 2A, and then it's A units between them. And then, of course, the minor axis in both examples goes the other direction, and that would be B units from the center, or a total of 2B all the way across. Again, just some more visuals here. Here, they're showing you where the foci come into play. So notice that the foci always have to exist on the major axis, whether the major axis goes up and down, like the first example, or whether it goes left to right, like the second example. And in both of these examples, again, you're assuming that the center is at the origin. So if the center is not at the origin, then you have to, of course, take that into account. So here are the types of problems that I'm going to ask you. Sketch the ellipse by finding the center, the vertices, and the foci. There's a reminder for you of the foci equation. So take a note here, 9x squared plus 4y squared equals 36. We kind of know that this is an ellipse because of the fact that we have two square terms and the fact that there are different numbers in front of them. The truth of the matter is, though, we cannot make any conclusions right now about this ellipse because it's not equal to 1. So our first order of business is to make this equal to 1, which means you have to divide both sides by 36. So 9x squared divided by 36, that simplifies to be x squared over 4 plus y squared over 9 equals 1. And again, you can't do any calculations or make any conclusions until you have gotten it equal to 1. So if you take a look here now, remember that a squared is always going to be the larger. So in this case, we know that the ellipse is going to open from bottom to top because the larger value is with the y. So what we know is that a squared is equal to 9, which means that a is 3. What we also know is that b squared is equal to 4, which means that b is equal to 2. And if you're wondering if they're always going to be nice values like that, no, but for the time being, yes. The center of this ellipse is 0, 0, again, because there is no h and because there is no k. So in terms of what this is going to look like graphically, again, we already know that it's going to open, bottom to top, because of the fact that the larger value is with the y. So we know that the center is here at 0, 0. For the vertices, we know that the vertices have to be a units away on the major axis. So because a is equal to 3, and because the vertices have to exist on the vertical axis, we know that the vertices are at 0, 3 and 0, negative 3. So 0, 3 and 0, negative 3. Then the foci. So to find the foci, you're going to have to use the equation that c squared equals a squared minus b squared. So c squared is equal to 9 minus 4, which means that c squared is equal to 5, which means that c is equal to radical 5. So the fact that c is equal to radical 5, and again, the foci have to be on the same axis as the vertices. So from the center 0, 0, they have to be radical 5 units up and down. So the first focus, a singular is focus, the plural is foci. So 0, radical 5, and then 0, negative radical 5. So again, you could, when you go to graph these, you should make them even more precise. What does the B tell you? Well, the B tells you how far you're going in each of these directions. So again, this would be at 2, this would be at negative 2, this would be at 0, 3, this would be at 0, negative 3, and the foci, which is the square root of 5, which is approximately 2.23. Those would, of course, be here and here. And again, it's a little tricky for me to graph using my stylus, so your examples in your notebook should obviously be even more precise than mine. So let's go ahead and try another example here. So again, you are going to graph this ellipse by finding the important information. Our first order of business is the fact that it cannot be equal to anything other than 1. So you're going to have to go ahead and divide everything by 400. So 16x plus 5 squared divided by 400, you're going to reduce the 16 and the 400. Turns out that it goes in exactly 25 times. So x plus 5 squared is going to be over 25 plus y minus 4 squared. When you divide 25, y minus 4 squared by 400, 25 goes into 400 16 times. And then, of course, it's always equal to the magic number 1, which it has to be. So from here, we can see that the center is not going to be at 0, 0. The center, of course, is always the opposite h, the opposite k. So with the x's, you're going to get negative 5 and positive 4. That's going to be your center. Then you're going to look for the larger denominator. So the fact that the larger denominator is with the x this time is how I know that this ellipse is actually going to be graphed from left to right. So starting with negative 5, 4, there is my center. And again, I know that the ellipse is going to look like this. And if I want to find those exact values, that's what I'm going to do now. So from here, I'm going to say that a squared is equal to the larger value, which of course is 25. That means that a is 5. That means that b squared is equal to 16. So that means that b is equal to 4. So from here, I know that the center is negative 5, 4. Then if I'm going to find the vertices, remember that the vertices have to exist on the major axis. So in this case, that means left to right. So I have to go 5 units to the left of the center and to the right, which is going to put those vertices at negative 10, 4. And then 0, 4. So please note that my right-hand part of the graph here should actually be like this. Again, just trying to save a little bit of time there. I'm not really sure how to erase. And then the foci. So to find the foci, you have to do c squared equals a squared minus b squared. So c squared is going to be equal to 25 minus 16, which of course is equal to 9, which means that c is going to be equal to 3. That means that the foci have to be 3 units to the left and to the right of the center. So that is going to put them at negative 8, 4 and negative 2, 4. And then again, what does the B tell you? Well, the B tells you that you should be 4 units in each of these directions on the minor axis. And again, you should actually be plotting these specific points, or you should at least be able to, if I was to ask you on a test or quiz to do so. Again, for the notes and the homework, if you cheat a little bit, that's fine. Here in example 3, notice that it is already equal to 1. So the fact that it is equal to 1, the only way that can happen and have these two numbers be the same, that happens if it's a circle and a circle only. So if you notice that it's a circle, you're going to kind of convert it back to the circle formula that we did last class, and you're going to graph it using those values. So if those denominators are the same, then you actually don't want it equal to 1. And in fact, you want to multiply everything by 9. And again, this only happens if the denominators are the same. So if the denominators are the same, you're going to multiply everything by 9, which is going to give you x squared plus y squared equals 9. You're then going to graph this using what you know about circles. So because there's no h and there's no k, you know that the circle has a center of 0, 0. And because you know that this should always be equal to the radius squared, you know that this circle has a radius of 3. Okay. Notice that there will be no foci, because if you did a squared minus b squared, you're just going to get 0. So this foci would actually be on top of the center, which there's a reason for that, which we'll talk about in a minute. But again, this is just a circle, which means 0, 0, and then 3 units in all directions. So for tonight's homework, it says graph the ellipse or circle, which means you have to determine which one it is first. And again, a circle is pretty obvious if they have the same coefficients, x squared, y squared, and if they have the same denominators. So speaking of what I just did about how do you know how stretched out the ellipse is, what takes a circle and turns it into an ellipse? Well, the way that you measure the ovalness of an ellipse is by using something called the eccentricity. And again, that's how you say it, the eccentricity. The eccentricity, which we're going to call E, is the ratio of the C, which has to do with the foci, and the A, which has to do with the length of the major axis. Notice that your eccentricity always has to be between 0 and 1. And then over here, the larger the eccentricity is, the more oval your ellipse will appear. Why is that the case? And again, just back, I don't know if you know that when they first were trying to figure out the planets and how they orbited, they originally thought they were circles, and it actually took them a while to figure out that they were ellipses because they really couldn't identify the foci. So because you're trying to find the ratio of C over A, over here in the left-hand example, if you're talking about foci being close to the center of the circle, and you're talking about the ratio of that with A, which in this case would be this distance right here, if you try to find a ratio like that, you're going to get a small number close to 0, which means you're going to have a shape that is more circular. Over here on the other side, let's say that you have a foci that is far away from the center. If you then try to find the ratio with A, which is the distance to the end, you're going to get a value that's much closer to 1, which means you're going to have a much more oval shape. So again, generally speaking, the larger the eccentricity, the more oval your graph should appear. So similar problems to what we did, except now it's asking you also for the eccentricity. It's not actually asking you for the graph, although you should be able to do that. And again, take a look at our equation here. Notice that it is not quite in the format that we want, which means we're going to have to do some rewriting, which means we're also going to have to do some completing the square. We've done completing the square review now twice, so you should hopefully remember. So first things first, I'm going to take all my x terms and put them together. And I'm also going to factor out whatever is in front of the x squared because completing the square only works if there's a positive 1 there. So when I put those terms together, I'm going to get 4x squared plus 8x. And then I'm going to leave a little space because that's where I actually have to complete my square. Then I'm going to locate my y terms. In this case, I don't have to factor anything out because it's just a positive 1y squared minus 6y. I'm going to leave a little space, and then I'm going to move the constant to the right side. So again, we have to complete the square. Please make sure you understand why I've set this up the way that I have. To complete the first square, half of 8 is 4, squared is 16. But here's where you have to be a little bit cautious. By adding a plus 16 there, because of the fact that there's a 4 on the outside, you didn't really add a 16. You really added a 64, which means you have to make sure you add the same quantity over on the right-hand side. A little bit easier in the middle, half of -6 is -3, squared is 9. Since there is no coefficient out front, you're just adding 9. So go ahead and take your 4, go ahead and rewrite this as a quantity squared, which is going to be x plus 4 squared plus y minus 3 squared. And then -57 plus 64 plus 9 gives you 16. Remember that this is no good in terms of answering questions, so I'm going to have to divide everything by 16. If I divide everything by 16, I'm going to get x plus 4 squared over 4. Then I'm going to get y minus 3 squared over 16, and that's going to give me equal to 1. So this is now the equation of the ellipse, and I'm going to have to go ahead and answer some questions. If you notice that the larger value is with the y, that's how you know that the graph is going to go from bottom to top. And again, even though I'm not asking you to graph it, you would have to make sure that you know how to do that. So here's another screen just to give us some room. So because of the fact that the graph is opening from bottom to top, that means that the larger value is a squared, which means that a squared equals 16, which means that a is equal to 4. So the center, going back to the equation that we had on the previous slide, it's opposite h, opposite k. So that's going to give you a center of -4, 3. And again, because of the fact that your graph is opening in the vertical direction, that means that the vertices have to be 4 units away from the center, up and down. So 4 units up would be -4, 7. 4 units down would be -4, -1. The foci formula, which you see in the right-hand corner there, c squared is always going to be equal to a squared, which is 16, minus b squared, which is 4, which means that c squared is equal to 12, which means that c is equal to the square root of 12, which of course is equal to 2 radical 3. So remember that the foci have to also be on the major axis, so you have to be 2 radical 3 units away from the center in the vertical directions. So your foci are going to be located at -4, and then 3 plus 2 radical 3, and 3 minus 2 radical 3, and I'm fine if you kind of just write it as such. Last but not least, for the first time, we're going to find the eccentricity, which again measures the ovalness of this ellipse. So to find the eccentricity, you're going to do the c over the a. So the c value was 2 radical 3. The a value was 4. And if you go ahead and reduce that, you're going to get radical 3 over 2. So that tells you how oval your ellipse should actually be. And again, if I asked you to graph it with all these specific values, you should be able to. For now, if you can find the different pieces, that's really kind of good enough. One more like that, and again, if you're feeling confident, this is kind of as hard as it gets in terms of being able to complete the square and find all the necessary things. So if you wanted to pause and try it, go for it. Otherwise, let's go ahead and do it together. So first off, let's locate all of the x terms and then factor out anything that we don't want. So I'm going to factor out a 16, which is going to give me x squared minus 2x, and then I'm going to leave a little space. Then I'm going to look for my y's. I'm going to have to factor out 25 here, which is going to give me y squared minus 2y. And again, I'm going to leave a little space, and then I'm going to go ahead and move the constant to the other side. Again, notice how in these problems, I'm giving you ones where there's a common factor so that the numbers wind up being nicer. I will most likely do that going forward because, there's already enough going on. In both of these cases, you're going to complete the square by adding a +1, but again, you have to be careful because of the fact that this +1 has a coefficient out front. You're really adding 16. Because this +1 has a 25 out front, you're really adding a 25. So 16 times x minus 1 squared plus 25 times y minus 1 squared is going to equal 25. Remember then that you have to divide everything by 25 in order to get it equal to 1. So when you divide 16 by 25, so you're going to get a coefficient of 16 over 25, which means that when you put it in the denominator, you're going to write it as 25/16. Hopefully that would make sense because it's kind of multiplying by the reciprocal, but in reverse. So if you now did the keep, change, flip, that's how you would get 16 divided by 25. But because of what you want to solve for, it's actually easier to leave it in the denominator as 25/16. A little bit easier on the y values because the 25 cancel and you're just left with 1, giving you an equation of x minus 1 squared over 25/16 plus y minus 1 squared over 1 equals 1. Again, look at the two denominators. Hopefully you realize that 25/16 is larger than 1. So that's how I know that this is going to be an ellipse that goes from left to right. Again, a little bit, just on that next screen here, just to get a little bit more room. So a squared is the larger value, which is 25/16. That means that a is equal to 5/4. The center, if I look back to my previous screen, remember it's opposite x, opposite y. So the center is 1, 1. Again, this is an ellipse that goes from left to right, which means that my vertices have to be 5/4 units to the left and to the right of the center. So remember that 1 is, of course, equal to 4/4. So if I go 5/4 to the right, I'm going to get 9/4, 1. And if I go 5/4 to the left, I'm going to get -1/4, 1. Then to find my foci, so c squared is going to be equal to the larger 25/16 minus the smaller, which is 1. And of course, a better way of saying that would be 16/16. That means that c squared is going to be equal to 9/16, which means that c is going to be equal to 3/4. And again, I'm trying my best to have the numbers be nice because why not? The foci now have to be 3/4 units away from the center. So 7/4, 1 to the right of the center, and then -1/4, 1 to the right. Okay, so then from here, the eccentricity. So the eccentricity is going to be c over a, which is going to be 3/4 over 5/4. Cancel the 4s, which means the eccentricity is equal to 3/5. So again, from here, please make sure that you could, in fact, find the answers. Sorry, I think that this should just be positive 1/4. I knew that looked wrong. You can't have the vertices and foci on top of each other. That wouldn't make sense. So you have a positive 1/4 for that second focus. Sorry about that. Okay, so then the last thing you have to be able to do here is you have to be able to find an equation given some characteristics. I've given you some reminders here, and I've also drawn the picture. Again, this is all the information that you would be given because of where the vertices are and because of where the foci are. That's how you know that this would be a vertical ellipse as opposed to being a horizontal one. So from here, if we know that the center is 0, 0, we know that this is actually the more simple version. So we have x squared plus y squared equals 1. And then again, because of the fact that it is opening up and down, that's how we know that the larger value, a squared, should go with the y, and the smaller value, b squared, should go with the x. Take a look at the vertices here. So since the vertices are 8 units away, that's how we know that a is equal to 8. The foci have to do with c. So that's how we know that c is equal to 4. In our equation, we have to solve for a squared and b squared. So we have to solve for b squared. So notice that this first equation is the equation for the foci. All I did was rearrange it so that the b squared was now alone. So b squared is going to be equal to a squared, which is 64, minus c squared, which is 16. That means that b squared is going to be equal to 48, which means that the formula for this ellipse is x squared over 48 plus y squared over 64 equals 1. And again, the fact that you wind up with non-perfect squares doesn't really matter because you're not even graphing it. Another one here, and again, this is the only information that you would be given, but because of those values, that's how you would know that the ellipse would be opening from left to right. So take a look at the major axis being 6. If the major axis is a total of 6, that means it has to be 3 units on either direction, and that's how you know that A is 3. Based on where the foci are, that's how you know that C is equal to 2. Again, b squared is always going to be equal to a squared minus c squared, which means that b squared is equal to 5. So again, because the center is 0, 0, that's how you know there's no h and there's no k. Who gets the larger value? Well, because it's opening left to right, that's how you know that the x's get the larger value and then the y's get the smaller value. So this is my equation of this ellipse. And our final problem of the day, which again, if you're feeling brave, feel free to go ahead and try it. Otherwise, let's just do it together. So here, they're telling you where one of the foci are, and they're telling, so 0, 0 is a focus, and 4, 0 is a focus. That means that in between them has to be the center. So that's how you know that the center is located at 2, 0. Then if you take a look at the major axis, again, if they're telling you that the major axis is 8, half of that value has to be A, which means that A is 4. And then because of the fact that the foci are exactly 2 units away from the center, that's how you know that C is equal to 2. So B squared is equal to 16 minus 4, which means that B squared is equal to 12. Because of the fact that you have a center that's not the origin, don't forget to put in your h and k. So x minus 2 squared plus y squared, remember it always has to be equal to 1. And then in terms of the denominators, remember that the larger value always has to go with whatever direction it's opening. So 16 is larger than 12. And because I know that it's opening from left to right, that's how I know that this is my final